Hi, everyone, and welcome to the fifth webinar in our virtual classroom series. We've already covered all aspects of upgrading, including performance stability and moving to multi-tenant. Today, we're going to shift focus just a little bit and talk about database migration strategies in depth.
And there are so many migration strategies that come to my mind. What if you have a 300 terabyte database on AIX that you would like to migrate to Exadata? Or if you want to go from Windows to Linux? Or what if you have an SLA that dictates you can only have 30 seconds of outage for that very important database? Which one to choose? Fear not, we will enable you to make the best possible choice.
Wait a bit, Daniel. I think we forgot Data Pump. There are so many Data Pump fans out there, as it is really a powerful and so flexible tool. So let us share our best practices and secrets and tips and tricks with the audience. Then your next migration will become a big success and run absolutely flawless. So please enjoy the next 120 minutes about all the different migration strategies.
This is Roy Swanger. He is our Vice President for Upgrade, Utilities, and Patching, which means that he also covers Data Pump, SQL Loader, and Data Patch. Roy has a strong technical background, so even though he has moved up the ranks, he still enjoys to get his hands dirty while he types in the terminal.
I have the pleasure today of introducing Mike Dietrich, who really needs no introduction. Most people in the audience know that Mike is the preeminent authority on Oracle database upgrade and migration. What you may not know is that he gets his customer focus and his depth of technical knowledge based on a career that started in Oracle support, went to pre-sales working with customers, and for the last many years has been a product manager in the database development organization. So that's why you can find such great technical information on his blog. And of course, he's a very valuable person to follow on Twitter.
And this is Daniel Overby Hansen. So Daniel joined our team more than a year ago, and we are absolutely happy to have him on board. So he is our Senior Principal Product Manager for cloud migrations, but he does much more than cloud migrations. So when you go to Daniel's blog, dohdatabase.com, you will find out that Daniel really likes to dig deep into tech topics, and he blogs about all things around upgrades and migrations on his blog. Before we start talking about technology, a few organizational things up front. So at first, the slides. You can download the slides already from the Upgrade blog. Go to mikedietrich.com/slides and then to Webinar 2021, and there you will find the slides for today's session, ready to download already. Second, the seminar will be recorded. The recording will be made available a few days after today's session, also on the Upgrade blog. So please go to mikedietrich.com/videos and find the recording, not only for today's seminar, but also for all the previous sessions we did. Feel free to share with everybody who is interested in database upgrades and migrations. Then, very important, we will try to answer all your questions, but please make sure you use the Q&A and not the chat window. Please use the Q&A for all your questions. And at the end of the seminar, we will be still around a few minutes to answer all the remaining questions. The seminar will take approximately 120 minutes again, and after an hour, we will do a 5-minute break. And finally, the seminar gets broadcasted as usual in HD. So in case you have any sort of resolution or displaying issues, please just simply disconnect from the Zoom session and connect again, and then everything should be fine. And now let's go forward. Enjoy. So let us start from here with a quick migration strategies overview. What is a migration, and what makes a migration being different from a database upgrade? While with an upgrade, we just update the dictionary usually, with a migration, we really need to read data and transport it from the source to the target site. So the size of the database for a migration usually matters a lot for the duration of our migration. And what is the best technique? That's a question you may ask yourself, and it's no secret, I guess, that we get these questions many, many times every week. So we have so many techniques available: data pump, transportable table spaces, full transportable export import, data guard, incremental backups on top, or GoldenGate. And it's always a balance between simplicity on one side and downtime requirements on the other side. So basically, either it's a very simple approach, or you go for less downtime, but then it gets more complex. So today, we will give you detailed insights in all these techniques. So I started already with the migrations overview, and then you see in the big green slide here, we will cover data pump, data guard as a migration vehicle, Armin and Armin techniques, transportable table spaces and full transportable export import, and GoldenGate. And at the end, we will guide you also through performance after migration to make sure you have the right performance data when you migrate your database. And this is our plan for today. And now I hand over to Daniel, because Daniel will start now with data pump.
Thanks, Mike. Let's look at the first technique that we will discuss today, which is data pump. I would say that data pump is kind of the screwdriver in your toolbox. When you do your home improvement project, you bring out that big sledgehammer and you come with your round saw and all your power tools. But at the end of the day, you've always used the screwdriver. Just for one tiny piece of your home improvement project, you've used the screwdriver. And it's kind of the same with data pump. Even for those huge migrations where we roll out the big artillery and come with zero downtime migration and so forth, for one part of the migration project or the other, we've almost all the time used data pump. Why is that? It's because data pump is so easy to use. Combined with its flexibility and the many capabilities, we often find data pump to be a good candidate. But the flip side to using data pump is that for large databases, it takes too long, or it actually takes a while to do the export, import the data again, and rebuild indexes and so forth. But despite that, data pump is really a good tool. So let's discuss the basics about data pump. The default way of using data pump is to use it in dump file mode. When you do that, you export the data from the source database and put it into a dump file. You can then transfer the dump file over the network to your target database, and then import from the dump file into the database. In contrast to that, you can use data pump in network mode. When you do that, you simply invoke import on the target database directly. It'll connect to the source database and load all the data via the network link and put it into the target database. When you use data pump with dump files, you must have access to the file system of the database. And you need additional disk space to hold the dump file as it gets created by the database. But since this is the default way of using data pump, you get access to the full functionality of data pump when you do it in dump file mode. With network mode, you must have SQLnet connectivity between the two databases. And the bigger the database, the better the connectivity between the databases has to be. But the good thing is that you don't need additional disk space to hold a copy of the dump file. But, and we will cover this in details a little later, when you use data pump in network mode, there is limited functionality. Also, let me briefly touch upon the architecture of data pump. The data pump functionality itself is stored inside the database in PL/SQL in a package called DBMS data pump. It uses DBMS metadata a lot, but the data pump functionality is stored in that PL/SQL package. When you have to do export, you can use the utility XDP as a wrapper or cover for the data pump functionality, but all it does is actually to call functionality inside DBMS data pump. And it's the same with the import and when you use the impdp command line tool. How do you use data pump? First, you must have privileges to use data pump. For that purpose, in the database, there are two predefined roles that grants full access to do exports and imports. You should exercise caution when you grant these roles because they are very powerful. And then a word of advice, you should never use as sysdba to do anything with data pump unless you are explicitly told so by support. Inside the database, sys as sysdba has access to some internal functionality that you don't want to use when you do data pump. In addition to that, data pump must have access to a directory object that points to a directory that exists in the file system and that the database has privileges to write to. Data pump uses the directory object to store DOM files and log files and potentially also SQL files. You should be aware that data pump runs server-side. This means that the directory must exist on the database server. So even though you sit at your client and start a data pump export or import, the directory must be accessible to the database server, not to your client. And finally, you should set the streams pools to a reasonable value. What is reasonable? Typically, it's between 64 and 256 megabytes. If you have enough memory in your system, just bump it up to 256 and you should be all good. Data pump uses advanced queuing to communicate between the different workers. And since advanced queuing uses the streams pool, you should ensure upfront that it is set to a reasonable value. Now that we've ensured that we can use data pump in our database, it's time to scratch the surface. And I know that Roy will take us through that.
Thanks, Daniel. And let me take your handyman metaphor just one step further, because it's not just about using the right tool for the job, but it's about using the tool in the right way to get the best results. So let's talk about some best practice for data pump so that you can get the best results out of your migration. The first bit of advice is to use a parameter file for your data pump parameters instead of putting them all on the command line. It is possible to put every parameter on the command line, but then you're going to find that it ends up wrapping and going through multiple lines in your terminal window, and it can be pretty hard to read or to proofread. If instead you put your parameters in a parameter file, or what we call a par file, then it's much easier to read, much more organized. And then you also don't have to deal with the quoting and escape characters that might be particular to one operating system or another, especially when you have special characters and things like the query parameter. Now, for consistent exports, and by what I mean there is every object in your database exported as of the same exact point in time. If you want that, then what you need to do is either have your database completely quiesced, which can be difficult, or set flashback time or flashback SCN. And that way, every object, every table, every index will be exported as of that timestamp or that SCN. Otherwise, what will happen is individual tables will be consistent within their partitions, but after we finish one table, the next table might be exported as of a later SCN. Now, why isn't that the default, a consistent export? Well, the reason is that when we perform a consistent export, we have to retain undo for the duration of the export, and sometimes that could be for hours. So when you're going to have a consistent export, make sure that you have enough undo retention to handle that. Otherwise, the export will end up failing with the snapshot segment too old, as some of the data we need gets aged out of your undo retention. In terms of performance, it's a really good idea to gather dictionary stats right before an export. The reason for that is that we're going to be performing a lot of queries on your dictionary as part of that export. So by having the dictionary stats good and current, our queries on user dollar, obj dollar, source dollar, tab dollar, and so on will just run that much faster. We also advise gathering dictionary stats immediately after an import. And the reason for that is that we will have added a lot of rows to all those dictionary tables as we create those metadata objects in your database. So again, having good dictionary stats is just good for performance across the board. So if you want to know how to do this, we would recommend gathering schema stats on sys and system. And you can do this individually with the first statement that you see there, or in a multi-tenant container database. Remember our last webinar where we showed how to use catcon to do this? That statement, the lower one here, shows you how to gather dictionary stats across an entire multi-tenant container database. Whenever you're running data pump, it's a good idea to get diagnostic information because you don't know in advance whether you're going to get the performance that you need or the results that you need. It's just good to have that logging, and that's why we produce our log files. If you specify log time equal all and metrics equal yes, it adds really useful information about performance and parallelism to your log files. So let me give you an example here. If you don't put those diagnostics on, just take the defaults, then you get the typical what you've imported in what order and how many rows and so on, and that's okay. But then look at all the detail you get by saying log time equals all and metrics equals y. Not only do you see that the parallel workers are kicking into gear to import multiple table objects in parallel, but also you see how long every individual table took. And this can be really useful when we're diagnosing performance issues because then we can focus in on the right time for an AWR report or an ASH report and on the right object to see if there's something like maybe lob columns that are affecting performance. Now, speaking of performance, one of the main tools to speed up data pump is parallelism. And you can specify parallel on your command line or in your PAR file. And our typical advice is to set parallelism to be 2 times the number of CPU cores. Now, CPU cores is not the same as CPU underscore count, that Oracle parameter, and it will differ based on your operating system and processor architecture. On an Intel processor, CPU count is 2 times the number of CPU cores, but on Spark Solaris, on PowerPC, I believe the hyperthreading factor is something like 8. So you're going to have to know your hardware in order to get the optimal parallel setting. Since 12.2, we have parallel export and import of metadata for dump file jobs, but we didn't add parallelism for our transportable jobs until 21c. That's for both transportable table space and full transportable. And sadly, we still don't have parallelism for network mode. That has to do with the fact that we're exporting from one database simultaneously while importing into another. So that process is very different than when we export everything to a dump file and import it later. Another thing for performance purposes, it may seem a little counterintuitive here, but exclude statistics when you export from a database. The reason for that is that exporting and importing statistics are both relatively slow compared to just building the statistics on the import side after the import. Now, the syntax for excluding statistics is slightly different for a regular dump file job than for transportable table spaces, but it's a good idea to do this in both cases. Then after the import, refresh the statistics on your target side. It'll be faster, and it'll take into account any differences in the layout on that new target system. Another good thing to do on import is to convert your old basic file lobs to secure file lobs. Secure files were a feature added way back in 11.1, and they've been fantastically successful in improving performance on tables with lob columns. The main reason for that is that basic file lobs, the old style, prevent us from doing any parallel DML, and that means selects as well as updates and inserts on a table with a basic file lob column. So if you convert to secure file on the fly as part of your data pump import, you'll find that your activity on your lob tables has a lot less contention, and it's just so much faster. Plus, there's other functionality that you can add if you have the compression options, security options. You can add deduplication, you can add encryption of those logs. When you are exporting in parallel, please make sure that you're going to use multiple dump files. We like to wildcard as a way to have multiple dump files because that allows you to have up to a default of 99 files with %u, that's the original way of wildcarding, or with %l, a practically unlimited number of dump files. It goes up to just over 2.1 million. With a combination of wildcarded dump file names and setting the file size, what you can do is have a set of dump files that are kind of bite-sized or easy enough to transfer around individually. So not a big monolithic dump file that could be difficult to store or manage. And then you can have enough of them that you can still hold your entire database, even when you get into terabytes. And then finally, for performance, you might want to use compression to speed up your export. Originally, we just were able to say in 11.1 export with compression equal all, for example. We've now added more compression algorithms in more recent versions. Our recommendation is to use compression algorithm equals medium. Now, this does require the advanced compression option. And there are 4 choices now for compression algorithms. The basic one, that's the one that we started with back in 11.1 and 11.2. Starting in 12.1, you can specify low, medium, or high. And based on our testing, we recommend medium for most cases. It's going to give you good performance and good compression. So here's some examples of exports I did using our test version of a populated eBusiness Suite database, 2 different schemas, the XLA schema and the MSC schema. Both of them between 5 and 6 gigabytes of data, so not trivial, but not massive. But what you can see is the ratios that you get. Medium gives a good compression ratio, better than basic, better than low in the first case, and same as basic, and still better than low in the second case, and it gives you really good performance. With high compression, the performance can really vary. You can see in the first case, the time for high compression wasn't that much slower than medium, but in the second case, it was a factor of 4 different. And paradoxically, sometimes the low compression can actually take longer than medium. So the bottom line here, if you're going to use compression with Data Pump, we recommend saying compression equals all and compression algorithm equals medium. So that's some best practices for Data Pump. Now let's talk about a few special use cases where you might want to consider using Data Pump. The first of these is when you're working with DataGuard. Now, when you import into a DataGuard environment, so you're importing into the primary, it'll work seamlessly. All of your import operations will get replicated to the standby via redo apply. So we're not skipping anything on your primary when we're importing with Data Pump. You do want to make sure that your standby file management is auto, and might want to have your DB file name convert as well. Now, if you're doing this to create a pluggable database, what you can do is you can create your pluggable database on the primary. Now, that create pluggable database command will get replicated to the standby, and you'll have an empty PDB on both sides. Then you can simply import into the new PDB on the primary. Everything will get replicated to the standby. Just works perfectly. Now, as a fallback mechanism, you might want to use Data Pump if you're upgrading, and especially if you have to, say, raise compatible as part of your upgrade operation for whatever reason. So you're going, in this case, say 11.204 to 19c, and if you raise compatible, you wouldn't be able to downgrade. But what you could do is you can export from 19c with the version parameter and say version equals 11.204. What we will do then is we will export from your 19c database, and then you can import that dump file back into your 11.204 database. Now, if there's anything in 19c that isn't supported in 11.204, we will skip those objects in 19c. So some examples there. What if you had a table that had a name that was longer than 30 bytes? You're using long identifiers. Well, we would not be able to export that table and bring it back to 11.204 because we can't just truncate the table name. But for things that are supported in the older version, we can still go back even from 19 all the way to 11.204 if needed. So you import into the database and everything should be fine because that's really an 11.204 dump file that we've produced. So again, to create that dump file compatible with the lower release, use the version parameter. You could say version equals compatible. So let's say you are on a 19c database and you had left compatible at 12.2. You could do that and you could get a 12.2 dump file out of it. Or you could, of course, say version equals latest. That's going to be the default. That's whatever you're using in that database. In terms of network mode, importing over a DB link can be really useful when you don't have access to disk space to store a dump file. It could be useful for migrating to the cloud, for example, if you don't want to copy a dump file up to object store before importing it into the cloud. When you import over a DB link, what we're doing is a simultaneous export from the source and import into the target. And that's why, as I mentioned earlier, that's why we don't have parallel metadata yet, because we're just grabbing individual objects and immediately importing them into the target system. Import over a DB link is fully restartable, just like any other data pump job, but there are some differences. For example, I mentioned no metadata parallelism. Also, we have some limitations that are born of using DB links. Over a DB link, you're not allowed to select long raw data. We did come up with a clever workaround for that. If your source database is 12.2, you can specify access method equals direct path, and then instead of using external tables to do an insert as select over that DB link, we will move using direct path, and you can move those long raw data tables over a DB link. We can use some parallelism over a DB link for data, but we're limited to doing partitions or subpartitions or tables in parallel. What we can't do is invoke the parallel query engine on a large unpartitioned table and have all those PX processes doing things over the DB link. That is, again, a limitation of DB links and not something that we're able to get around. The other thing is that importing over a DB link is not something you can really do for a downgrade. You couldn't log into an 11.204 database, create the DB link to 19, and pull the data over that way. You would have to use dump files. Well, so that's the basic best practice and a few use cases for data pump. At this point, let me turn it over to Mike to give you some more looks at advanced features that you might want to take advantage of.
Wow, these were a lot of good best practices and use cases presented by Roy, but we have more to say about data pump. Let's cover a few helpful advanced features. And the first one may be not news to you. You can easily tell data pump, hey data pump, please give me all my SQL statements. So you set SQL file equals a file name in your imp par file, and then you kick off data pump import. Afterwards, instead of importing and creating the objects, data pump gives you all the code statements in that SQL file. So you get the create users, the grants, the quotas, of course, also the tables, the index statements, and so on. And if you'd like to, you can also use exclude or include to just get a subset of the information. So that is straightforward. But what if you would like to program with data pump? And you would like to use the PL SQL API data pump secretly uses in the backend. Now, of course, you can study the documentation and find it out by yourself, but there's an easier way. So let's say, simple example here, I would like to know how to use data pump API and setting the parallel degree here to 8. So it's easy in the documentation. If I look it up, dbms data pump set parallel and then job handle and the degree. Okay. Simple example, but I want more. And how do I get that? You take a test environment and you set SQL trace event 10,046 level 4. Level 4 here is important because otherwise you would get way too much information. We don't need that. Level 4 is fine. Then you run on your test environment, you import, and afterwards you check for the trace file which is associated with that SQL trace. So it's the trace file or one of the trace files in your trace directory, which has no background process named in the trace file's name. And in that trace file, you find now how data pump opens the job. It starts the job at first, then how it adds a file. And finally, what we were looking for, how data pump with the API sets the parallel degree. So with that, you can use these code fragments, change it for your own needs, and then reuse them in your own programming. So that's very neat and very straightforward, and in many cases, easier than reading the documentation and trying to create the procedures by yourself. Then let us go to another topic. And the other topic would be, we would like to import thousands or hundreds of thousands of partitions and subpartitions. And if you ever done that, you know it takes a lot of time to create these objects. So what could we do? We could create the partitions in advance with a script and then use table exists action and set it to append. That's good, but it's slow. It's still slow. So how can we use that trick and then make it run faster? And here we need to tell data pump that parameter data option equals trust existing table partitions. Because if you avoid that, then data pump still runs a check for every partition and tries to match that with the information in the dump file. But when you tell data pump with data option trust existing table partitions, it will not do this extra check, and then it runs significantly faster in such cases. And then let's go to multi-tenant. As you know from our previous seminar, you can have up to 252 PDBs, or if you have engineered system, up to 4,000 and something PDBs. And if you run data pump now in some of them in parallel, there's a good choice that we called it the noisy neighbor syndrome, that you either disturb somebody else, or that is even worse, that you're depleting the resources of the CDB. Because by default, the number of data pump jobs running concurrently in one PDB is 100. Now, let's say you have 200 PDBs. You can do the math, what that means. If you start in all PDBs at the same time, a data pump export, and you have a high parallel degree and you request a lot of resources. If you set this parameter to auto, it takes still 50% of the sessions, which may be very high. So in case of such environments, it's a good best practice to limit the number of concurrent data pump jobs in a PDB. It doesn't have to be 2 necessarily. It could be 8 or something like that, but much less than the default if you have a lot of PDBs. Otherwise, as you see in the corner of the slide, you may receive this 93939 one error. Also, another noisy neighbor syndrome with data pump is then too many parallel workers in a data pump job, and that depleting the resource of the CDB. So you can also restrict the parallel degree in a data pump job with max data pump parallel per job. And the default here is also 50. So it's relatively high, or auto means 50% of the number of sessions, again, which is even higher in most cases. So if you had issues with that, or if you think there is a need to restrict that, use that parameter option. And that's it for now. And then I think Daniel is going on with DataGuard as a migration vehicle.
Okay, next up is DataGuard. And I love DataGuard, especially for migrations. Why is that? Well, because it is so fast, yet still it is so simple. And DataGuard is, in addition to that, something that many of us are already very familiar with. We use it in our day-to-day operations. Also, with DataGuard, you get the possibility of testing before go live by using snapshot standby databases. It's also very flexible. You can change to a different file system or a different storage layout, and you can even go cross-platform in some situations. The flip side to using DataGuard is that you must be able to install your old Oracle home on the new platform. So if you plan to go to the latest and greatest version of Oracle Linux, it might not be that you can install the old Oracle home on that new operating system, and in that case, you can't use DataGuard. The concept looked like this. You have your current database running on your old hardware, and the users are connecting to it. While the database is still up and running, you can build a copy of the database. In this example, I'm doing a duplicate from the active database, but you could also restore from a backup. After that, you configure redo apply to keep the two databases in sync. While all this has happened, the users are still connected to the database and it's still up and running. Then, at your will, when it's time to complete the migration, you simply do a DataGuard switchover. And typically, that only takes a few minutes. And if you have a well-behaving application that understands the events that are sent from the database before the switchover, it might be that the user doesn't even know that a switchover has taken place. A variation to this is to do migration and upgrade at the same time. And in this example, we've already built the standby database and configured redo apply. Now the users are connected to the old system, but now it's time to complete the migration. So we drain the source database, we disconnect the users, we ensure that all the changes from the primary database has been synchronized to the standby database. We then cut the connection between the two databases and do an upgrade of the database. When that has happened, we can allow the users to reconnect to the new and upgraded target database. In this scenario, we have additional downtime because we have to keep the database down while we do the upgrade. You will notice here that my database is no longer protected by DataGuard. Since we have cut the connection between the two databases, we only have one database that is not protected anymore. You can then, after that, build a new standby database, or if you prefer, you can use what we call cascading standbys. To use this approach, you build first a regular standby database on your new hardware. You then build an additional standby database, a cascading standby, but you connect that to the other standby database, not the primary. When it's time to complete the migration, you stop the synchronization from the old database, and the first standby now becomes the new primary, and the second standby is now a regular standby database. So by using this approach, you can ensure that your database is protected by DataGuard from the second that you do the migration. If you want, you can also squeeze in an upgrade when you use this approach. And I know, Mike, that this is something that you have used with customers with great success. Isn't it so?
And so it's time for a short custom example. And even though that project has happened many years ago, it shows us a good example how you can use DataGuard as a migration vehicle. So the customer here is Payback, and Payback belongs to American Express for a long while. They're headquartered here in Munich, and they run the largest customer loyalty program in the world with a card. So you buy something in a store which participates in a Payback program, and you get points which you can redeem later on for cashback or for other things. And you get vouchers and promotions and all that. And in exchange, you tell Payback a lot about your purchasing patterns. So that project was actually the second part of a project. The first one was a migration from HPUX to Exadata. And in the second phase, we got a new Exadata. So Payback was the second customer in Europe which had an Exadata, and this was a V1. And later on, they purchased an X22. So we got a 2-month project timeline to migrate a 14 terabyte database. Now you would say, oh, that's not a big deal. But at this point, it was quite of a deal because on the X22, it came with Oracle 11.203. And on the V1, there was 11.107. So we needed an example here, and we followed this from this Oracle support node, hardware and Oracle migration using DataGuard. So we used ARM and duplicate to create a physical standby database. Because the constraints here were that we couldn't install 11.107 software on the new Exadata. If you would have done so, we would have disconnected the storage cells right away. And upgrading on the current one, on the old one, was not an option either, because in the old days, that was way too complicated. In addition, the customer decided, oh, we have a network bottleneck, so we need a special InfiniBand cable to connect the boxes together with different InfiniBand standards and plugs. So that cable got shipped from the US. At this time, it wasn't on the Oracle price list. The idea was we restore a 14 terabyte database with Armin with the command duplicate for standby from active database. So in order to do that, the machines were cabled together with that special InfiniBand cable. And then we restored the database and let Armin do the work. So we experimented a bit, and it was clear that the best performance will be reached with 64 parallel Armin channels allocated. And so we reached more than 4 terabyte per hours over this InfiniBand connection. And the Armin restore of this 14 terabyte database took 3 hours. Now this runs online. Your production is still going on, so you have no interruption here. And then Payback was also an active beta tester of the new parallel upgrade. Now you would say, parallel upgrade, that's not new, that's 12. Many years, almost a decade now. Yes, you're right, but we had some customers who used it already in 11.203. So we gave those customers a special version for 11.203, and Payback was one of them. So database upgrade, including everything, took 20 minutes for this 14 terabyte system with the new parallel upgrade, which was 3 times as fast as the regular upgrade had taken. So this was a big success, and they went live on 3rd of July 2012, long time ago, and 3 weeks earlier than proposed. So we were faster in this project again. The total migration time reported was 4 hours. So 3 hours to restore the standby and for the recovery, then 20 minutes for the database upgrade, and 40 minutes for extra tasks. But in fact, only 1 hour is downtime, whereas the 3 hours upfront is not real downtime. The fear of the DBAs was only if they reported they did everything in 1 hour, that the next downtime window would have been much more tighter. So they went with 4 hours outage time, even though we had just 1 hour. And remarks here, yeah, we had a few plan changes, but we used AWR and we used especially SQL plan management to nail down statements. The physical standby as a migration vehicle was the key technology, and it allowed us several test runs, which is really important, and the copy time does not account for downtime. And you see already on the slide in the left lower corner, 2020 or 2021, I would say. Of course, Payback has gone through a next Exadata and another one. So today they are on 19.8.0, but we didn't have any bigger migrations. It's just the same technique. We do this when new Exadata is coming, physical standby as migration vehicle, and that's it. So let's go on with the next topic.
Interesting. The next topic is rolling upgrades with transient logical standby. When you use this approach, you can use your existing physical standbys to do a database upgrade. This is a well-proven approach that was introduced all the way back in 11.1 or so, and we have many customers that uses this approach. The advantage is that you can do an upgrade with less than 5 minutes of downtime, and the only downtime that you have to take is actually only a brownout while you do a data guard switchover. You can use this approach for upgrades, but you can also use it for other kinds of maintenance activities. But there are some things that you should be aware of. There is a restriction when you use logical standby, which means that you can't build a logical standby on the same hardware as the primary database, so you need additional hardware. Also, if you have an extremely busy system, you might end up in a situation where LogMiner, the process that extracts the SQL, simply can't keep up. And in addition to that, there are some unsupported data types. Some of them are mostly exotic, But if you're using such data types, or if you're generating so much SQLs that LogMiner can't keep up, you need to look into using GoldenGate instead. Before we move on, let's just briefly touch upon the differences between a physical and a logical standby. A physical standby database is synchronized with redo apply, which means that the individual data blocks are updated. So a physical standby is an exact copy, block by block, of the primary database. In contrast to that, we have the logical standby, and it works with a process called SQL apply. So instead of synchronizing the individual data blocks, we are re-executing the same statements from the primary database, but now on the standby database. So it's still an exact copy, but only when you look at it from a data perspective. A logical standby can run on a different version. The table structure can be changed, or you can, for instance, use partitioning in a logical standby, but the data will still be the same. How does a rolling upgrade work? First, you start out with a regular data guard setup with a primary and a physical standby. And redo is being sent from the primary to the standby database. Obviously, the users are connected to, in this case, the upper database, our primary database. The very first thing that we have to do is to set a guaranteed restore point. This will become very important later on in the process. Next, we prepare the database for being able to send SQLs by building the LogMiner directory. We can then change our physical standby into a logical standby. When we do that, it's very important that we use the keep identity clause on the alter database statement, because this ensures that the new logical standby will preserve the DB ID. This will become important later on when we need to convert it back into a physical standby. Now, users are still connected to the primary database and they're generating transactions. The primary database extracts those SQLs from the logs, and it sends the SQLs to the logical standby. So we're not sending redo information, but we're sending insert, delete, update, DDL, DML, and so forth. And those statements are executed on the logical standby to keep them in sync. And as with any other Oracle database, the logical standby still creates and maintains its own redo data. Now we can stop our logical standby and restart it in a new Oracle home, in this case 19c, and we can then do a database upgrade. And again, the upgrade itself will generate redo that gets stored on the logical standby. While this has happened, the users are still connected to the primary database, so now we have to send additional SQLs to the logical standby to keep the two in sync. When you want, you can now do a data guard switchover. So the users are drained from the primary database. We ensure that the two databases are in perfect sync, and we then allow the users to reconnect to our logical standby. So we have now disconnected our users. When they connect back, they connect into an upgraded database. But the downtime we needed was just enough time to do a data guard switchover, which is much faster than doing a database upgrade. Now, while the users are still using our lower database, we issue a flashback database on the upper database and send it back in time to before we started the entire process. We can then convert it into a physical standby. We stop it and start it in the new Oracle home. And we can then take all the redo that was generated on our lower database, the logical standby. We take that redo, send it to our physical standby, apply it. So all the changes from the users are now applied. The upgrade is implicitly happening on the upper database because of the redo generated. And now we have the two databases in perfect sync, but on the new version of Oracle. If you want, and this is optional, you can issue an additional switchover to send the users back to the other database, which was the original primary database. But if you don't care on which system that the users are connected, you can just keep them on the lower database and avoid the additional switchover. There are two ways that you can do rolling upgrades. There is the manual approach, which we introduced all the way back in 11.1, but it requires Enterprise Edition. It is a manual approach, so you have to take care of all the steps in between and call the commands in the right order. But our preferred way of doing it is by using DBMS rolling. It does, however, require active data guard. And in addition to that, the source database has to be 12.102 or newer. But the really good thing about DBMS rolling is that it is a much more automated and much more fail-safe solution. So I would really recommend that you use DBMS rolling instead of the manual approach. That was it about data guard. The next is RMAN.
As Daniel said, the next topic in migration is RMAN. And you might think of RMAN as being more about just backup and restore. So are we going to talk about just backing up from one system and restoring onto another? No, we're actually going to get a little more innovative than that because RMAN has some really cool features when it comes to migration. And probably the coolest of those is duplicating an active database, cloning an active database from one system to another over the network with just a single command. You might have thought that that was something that only multi-tenant can do, but you can do it on a non-CDB as well. It's a very simple, easy process. You can go cross-platform with it within same endian groups. The only real downside to this is if you're duplicating an active database, there might be considerable downtime if that database is large. So let's talk about this and show you some pictures. Let's say you have your users connected to your original database on your old hardware, and you've got your nice new server in with a new version of Linux on it. The first step when you're doing a duplicate from active database is we're going to have to disconnect those users. Now the database is up and running. We can issue that one command in RMAN, duplicate target database from active database, and that will copy the entire database over the network and instantiate it on our new server as we've connected to it over there. Once that database is instantiated, then we can connect our users again. So it's a very simple process, but it could be somewhat time consuming if you're dealing with terabytes or tens of terabytes of data. So in order to reduce the downtime, let's use another RMAN feature, incremental backups. Incremental backups are also simple, easy, well-tested, but the benefit to them is that they can dramatically reduce the downtime of this kind of migration. They can also go cross-platform. So let's take a look at this again. We have our source database running on our old version of Linux, new server without a database yet, running on the new version of Linux. And now instead of disconnecting the users, we start with a level 0 backup, which is essentially an image copy of all your database files. Bring that over to the target system. We restore the database and instantiate it over there. All the while, our users are still working on the production system. So now in order to catch up, we can issue a level 1 backup. Again, an online operation. The users are still using the database. But this level 1 backup will be significantly smaller than that level 0. It'll go much faster. Instead of hours, it's a matter of minutes in many cases. And if you need to, you can take multiple level 1 backups to get that increment as small as possible down into your allowable downtime window. Now, once you're ready to make the switch and go live, at that point, we do have to disconnect the users because then we need that final level 1 backup. We're going to bring that over, recover it on top of the previous level 0 and level 1 backups on the target system. And once that is complete, then the users can reconnect. So even though this entire process could take days, in many cases, if you have a tens of terabyte database, the level 0 backup followed by multiple level 1s could take quite a while. Because you're using those incremental backups, it's only that final incremental backup where you have the downtime, and that will usually be in that most tens of minutes. So that's a great technique. And you can use it in conjunction with wanting to do an upgrade on that new hardware. So what we would do is we'd go through that whole process just as we outlined with the level 0, level 1 backups. But now, for that final level 1 backup, when our users are not connected, we take the level 1 incremental backup, restore it into the target environment, and then we can open the database in our new 19c Oracle home and upgrade it, and then let the users connect to it. So yeah, there's still a little downtime here for that last incremental backup and for the upgrade, but it's not downtime to copy that entire database over the network. It's a wonderful technique for reducing the downtime of migrating to new hardware and performing an upgrade. So RMAN is a great way to get a database from one server to another, and you can even use incremental backups to reduce the downtime and combine it with a database upgrade if you want to upgrade on that new server. But there are other techniques as well that might be useful when you want to move entire database files and not have to do an upgrade when you're doing this migration. One of those is transportable table spaces. So I'll give you the basics of transportable table spaces, and then Daniel can get you into some of the nuts and bolts. The first of the basics is endianness. We often talk about cross-endian migration or big endian platforms, little endian platforms. And really what we're talking about there is whether the high order byte in a representation of data is first or last when it's encountered by the operating system. Sort of like having some languages that read left to right and others that read right to left. The main point is, in order to move from one to another, we're going to have to do some conversion. Now, the Oracle Cloud is Linux x86 64. So it's not just Linux, but specifically a little endian Linux platform. That means that if you're migrating from a big endian platform, your database is going to have to be migrated using a technique that can modify the endianness of that database. So that means we can't use DataGuard in that case. We can't use just an RMAN backup and restore. We're going to use something like data pump, transportable table spaces, or full transportable export import. So when I say big endian platforms, what I mean are things like the HP platforms, PA Risk or Itanium, the IBM platforms, Z series, or Power-based AIX or Linux, or Spark Solaris. Linux x86 Solaris is a little endian platform. If you're going to migrate a database from one of these big endian platforms to Oracle Cloud, you bring the data files over, and then we convert them once they're in the cloud to be little endian. If you're not sure what your platform is in terms of endianness, because you might even be on an older platform, one that's not in that list of supported ones, such as Apple Mac OS. Well, that was a big endian format when we produced the server on Apple Mac OS, because that was back in the days of the PowerPC-based Mac OS. Now, of course, we've got Intel Macs, but we don't have a server there. When we're moving things via transportable table spaces, we need to think about two very distinct sets of entities. Your metadata on the one hand, your users, grants, roles, constraints, triggers, all that kind of stuff, and then your data, the actual application data in your data files. So why do we have to think about these separately? Well, your metadata, when you create a user, what happens? We enter an entry in the user dollar table. There's a row added to obj dollar. All of that is happening in your system table space. So all of that metadata lives in the data dictionary in your system table space. Your data, on the other hand, lives in your user and application table spaces. At least it should. It's a really bad idea to put user data in the system table space, and you're about to find out one of the reasons why. See, when we have a system table space, that system table space has to be exported with data pump. And that's because the system table space has a bunch of things in it that already exist in any new database. So it's got not just your metadata about the application objects, but it's got metadata about system objects that shouldn't move into a new database. Your data files, however, we can copy the entire data file as a unit. And if we're staying on the same endianness, we can just copy it from one system to another. If we're going cross-endian, we can use RMAN convert, another great RMAN feature, to convert the data files. So if we take this a step further and we look at the differences between metadata and data, your metadata is tied to a specific database version. After all, what's Upgrade doing when we go to a new database version? It's modifying the data dictionary, and that can mean changing the representation of metadata for performance or functionality purposes. Your data, on the other hand, is independent of database version. So while your metadata will work only in a given database version, it has to essentially be recreated sometimes when we're moving it with Data Pump to a new version. Your data will work in the same or newer database version. You could actually have a tablespace data file that's been read-only since 9208 and still read that data in a 19c database. So that upward compatibility is there for all your data. Your system tablespace metadata only works in the same database architecture. By that, I mean non-CDB versus PDB. If you think about how dictionaries are represented in a pluggable database, a lot of the things in that dictionary are now metadata pointers into a CDB root. That's what we learned all about in our previous webinar about migrating to multi-tenant. So that's going to be very different between a non-CDB and that same database as a PDB. There are going to be some things in a PDB that are metadata pointers, which won't be the case in a non-CDB. Whereas your data table space works the same on different database architectures. A data file on a PDB is the same as a data file on a non-CDB. So given these differences, that's why when we're moving the metadata, we use Data Pump, because Data Pump does work across database versions, and it does work across database architectures. It's your do-it-all tool. I know Daniel referred to it as kind of your screwdriver. It's almost like a Swiss Army knife that happens to have a screwdriver on it. It can really do it all. So with transportable table spaces, the combination of moving metadata with Data Pump and moving data files as files, that means we can move a database to the same or newer database version. We can go from non-CDB to PDB or vice versa. We can go from a PDB back into a non-CDB.
Now that we've covered the basics, let's go a little into the details. The first that I would like to talk about is full transportable export-import. This is a way that you can use Data Pump together with transportable tablespace to make the process easier. The creation of metadata has become a lot easier if you use full transportable export-import. In this example, we have a 12102 database that I would like to migrate into a 19c PDB. This is one of the advantages of using transportable tablespaces. You can go to a higher version and a different architecture. But if you prefer, you can stay on 12102 and migrate into a non-CDB database. You get the full flexibility with transportable tablespaces. In this example, we have a system tablespace and a data tablespace in our source database. Normally, you would have a lot more tablespaces, sysocs, undo, and other user tablespaces as well. But for simplicity, in this example, I only have the system tablespace and my data tablespace where I store all the user data. In my target system, I only have a system tablespace because I haven't created any user data there yet. I haven't migrated into that database yet. You'll notice the colors are different to represent that they are of a different Endian format. When I need to migrate the database, I start by setting the data tablespace in read-only. The source database is still online, but since the user data tablespace is read-only, it does in effect mean that I have downtime. I can then copy the data files to the target database. I can then use RMAN to convert the data file. But please be aware that the conversion happens while RMAN copies the file to a new location. So if you have a 5 terabyte data file, you need an additional 5 terabyte to hold a copy of the data file that you can eventually use in your target database. This is one of the downsides of using this approach. You need double the amount of disk space. After that, I can start Data Pump and use full transportable export-import to plug in my tablespaces into the database. And after that, I can import all the metadata from the source database into the target database. When I say all the metadata, bear in mind that I already have all the table data. I already have all the index structures stored in my table space. So what I need to import is users, grants, triggers, PL/SQL, and so forth, which is much quicker than doing a full import. So normally this doesn't take that long. But I told you that we had downtime and then we had to copy the entire data file. I guess that really won't fly well with your 100 terabyte database. But this is where full transportable export import with incremental backups come into play. So we have the same scenario, 12102 database and a 19c PDB. We have the same set of table spaces, but we don't set the data tablespace read-only yet. First, we create a level 0 image file backup. And when we restore that in our target system, RMAN can convert the data file at the same time. But like with the previous example, we need to have enough room in the storage system to hold a copy of the data file. Then you can do an additional level 1 incremental backup and apply the latest changes from the source database to the data files on the target system. And you can do an additional level 1, and you can keep doing that as often as you like. For each incremental backup you perform, the faster the final incremental backup will be. Because now it's Sunday morning, it's time to complete the migration. So we start by setting the data tablespace in read-only. Now we have downtime on our system. I then perform a final level 1 incremental backup. So I take all the changes from the source database and put them into the data files on the target system. Now I can start data pump and use full transportable export import to plug in the data files, complete the migration by transferring all that metadata into the target database. So it's more or less the same process, but we use incremental backups to keep the downtime at a very minimal. I've prepared a demo that I would like to show you, where I use the Perl script that you can download from my Oracle support, which makes this entire process a lot easier. So let's go ahead. I'm connected to the source system, and I connect to the database. First, I query the status of blockchain tracking. It is disabled. So let's go ahead and enable it. I can see here this is a 12102 database. And I switch into my sales container. This is a PDB. And I can see here that I have a number of objects created already. Around 500 megabytes. So this is really just a toy database. All my objects are stored in the user's tablespace. I then connect to the target system, head into the database, and I just verify that this is a 19.8 database. I then create a new empty pluggable database called sales, and I open it. And I check here that I don't already have an existing table space called users. I then verify my encryption key store. I need to create a TD master key because this is an encrypted database. And now I can see that my key store is open. Then I go ahead and configure the Perl scripts from my Oracle support. I am connected to the source system, and I have downloaded the zip file. This is the MOS node from where you can download it. Simply unzip it and find the file xttt.properties. I've already filled it out with the information needed for this migration. I have the users tablespace that I want to migrate. My target platform is 13, which is Linux. I define some working locations on the source and destination, where I want to store my data files. the details of my ASM instance, a few parallel options to make it faster, and connection credentials to the target database, and also a connect string to both the source and the target database. I then transfer all the scripts, including the properties file, to my target system. Now I have to create the level 0 backup. So I simply just start the Perl script and I use the backup option. It'll automatically detect that this is the first time it runs and create a level 0 backup. I've configured the script so that it will automatically transfer the backups to the target system when that is done. And then I manually need to copy this res.txt file, which has some temporary information that I need on the target system. Then I'm switching to the target host. I already have the scripts there because I copied them from the source. I use the same Perl script, but I use the restore option. I head into ASM CMD and I verify that my data file has been restored. It hasn't been plugged into the database yet, but it's restored into ASM. Now on my source system, I can do an incremental backup. I simply use the same command, just use the backup option. It'll detect that there has already been executed a level 0, and then it'll do a level 1 on top of that. Copy the little res.txt file to the target system. And I can then use that incremental backup to restore my target data file. Now it's time to complete the migration. Downtime starts, and I want to perform the final level 1 incremental. I connect to the database. I go into my sales PDB, and I create a table just to be able to verify that all the latest changes are in my target PDB after the migration. Then I set the tablespace read-only, and then I can perform the final incremental backup. This warning is intended. It complains that the data tablespace is read-only, but that's okay. I copy that little res.txt file, and now on the target system, I can restore. And that's it. The data file has now been fully restored. Now I can import the metadata and plug in the data files to my PDB. On the target system, I connect to the database. I go into my sales PDB, and I create a directory that I can use with DataPump. I also create a database link that points back to my source database, and I just verify that it works. This is the parameter file that I use with DataPump. I've specified the name of my database link. Full equals yes, transportable equal always. That's a full transportable export import. Some best practice with transportable tablespaces, where the log file is stored, and then I specify the data files that I want to plug in. And then I simply just start DataPump, specify my parameter file. Because this is an encrypted database, I choose to be prompted for the encryption password. And off it goes. It starts by plugging in the tablespaces, and then it continues to import the metadata. There it is. It's done. A few errors that I can investigate later on. But let's go into the database and verify that the migration was actually successful. I connect to my new sales service. This is the new target PDB. And I just check from user tables that my cost2 table is there, which means that the migration is successful. All the data was transferred. So this is a really easy way of using transportable tablespaces with very minimal downtime by using the Perl scripts from my Oracle support. But very often we see that those huge terabyte-sized databases are also so important that it has to be protected by data guard. You could build the standby database after the migration, but it'll prolong the downtime window that we need. What if you want your database to be protected immediately after the migration with data guard? Well, you can do that. And the concept is that you build your target PDB, you configure the data guard already, and then you need to restore the table spaces from the source system to both the primary database and the standby database. And it's very important that you do the same restore on both of the systems all the time, because eventually when you need to do the data pump plugin, you must ensure that both set of data files are restored to the exact same SCN, otherwise it won't work. If this is something for you, you can head into this Moz node and find a lot more details and step-by-step instructions on how you can prepare your data guard system so that your database, your important database, is protected by data guard from the very second that the migration has completed.
As you've no doubt noticed, a transportable table space migration gives you a lot to think about. So let's organize those thoughts with a checklist of some good things to keep track of before and heading into your migration to help you make it as successful as possible. First of all, think about your target database and what you're going to do to make it match as closely as possible the source data that you're bringing in. When you create that target database, non-CDB or PDB, it has to have the identical character set to your source, because remember, we're not modifying the data inside the data file. So the data has to be the same character set, source and target. That's both the database character set and the national character set. The compatible setting on your new database has to be at or above the source database. You can't transport data that has, say, compatible 19c into a database that's compatible 12.1, because that compatible will govern whether some of those features in the data files will be understandable by the database. So we simply won't allow you to do the wrong thing there. The time zone should match source and target. Now, there are a few cases, such as with full transportable table space, where we can actually update the time zone when you go to a newer time zone in the target. But best practice, have your database time zone and time zone file version match source and target. It'll give you the least amount of problems. When you're performing your backup and recovery and dealing with incremental backups, it's best to have block change tracking enabled on the source database. The reason for that is simply performance. With block change tracking enabled, we will know exactly which blocks changed in that source database between the level 0 and the level 1 backup. So we don't have to scan the whole database to find changed blocks as of a specific SCN. It makes your increments go that much faster and reduces the downtime. When you're doing the conversion of incremental backups, or whether it's your level 0 backup or your level 1 backups, generally it makes sense to do that conversion on the target system, because your new target hardware is generally much faster than your old server. I mean, that's often why you're migrating in the first place, right? Use the Perl scripts where possible to do the conversion. Take advantage of the automation that the scripts provide, because more automation means less human error. Of course, doing that does require the Enterprise Edition on premises or Enterprise Edition Extreme Performance in the cloud, or being on Exadata. Now, when it comes to TDE, unfortunately, TDE encrypted databases are not supported by the Perl scripts. You can only transport TDE encrypted data files cross-platform on the same endianness anyway. You cannot transport an encrypted data file cross-endian. If you have encrypted data files, in that case, you're going to use regular data pump, which can handle that decryption and encryption of your data. The Perl scripts that we've mentioned are in this Moz note. Easiest way to look for it is with that V4 in the beginning, because there are different versions of this note for different source and target versions of transportable table space destinations. So for the V4, the most recent version of those Perl scripts, your source database has to be 10.203 or newer. Your target has to be 11.204 and newer. So some general best practices. Best practice is to practice. Yes, practice, practice, practice. Don't make the first time you use this technique be your go live window when you have to hit that minimal downtime. Make sure you've tested it, that you know what you're doing. This is not just a drag and drop kind of operation. I think that's pretty clear from the videos you've seen, from the explanations from Daniel and so on. It can be a little complicated. So start with a small database, prove it works in test, and then ramp your size up to a production size database, maybe even with a workload generator, so that those incremental backups are meaningful. Automate as much as possible. If you can use those Perl scripts, do that. If there are other things that you can automate, such as your application shutdown startup, the disconnection of users, and so on, do that as well. The more automation, the less opportunity for human error. Of course, save all of the logs and output from these operations. There are a lot of moving parts here, right? There's data pump, there's RMAN, you're doing incremental backups, you're doing roll forward recovery. You want to have all those logs so that you can look at what happened, and if there is an error, then it will be helpful in diagnosing it and getting support. And then have a cleanup procedure, whether you have that in case of a failure for rollback, or to validate your target on the as end result, or to repeat the tests. You want to have a cleanup procedure so that you don't have to just re-image your entire system every time you want to go through this practice. And finally, do make sure that your source database is offline when you're complete in your go live environment. Because what you really don't want to have happen is go through all this work, have your minimal downtime migration, and then find out that some of your users are still using the old database. And now you've got a betwixt and between situation where some users are on the new and some are on the old. So take that old database offline. So that's a little checklist for you about how to organize your thoughts and have a successful migration. Now, Mike can really take you through the whole process in detail, step by step.
Thanks, Roy. And let's do it together. Full transportable export import using the Perl scripts for incremental backups, and that step by step. So it works in 6 phases. At first, the setup phase, where we need to create a database or a pluggable database with certain parameters. Then we create an image file copy backup of our database. We roll forward with incremental backups in phase 3, and we can repeat this phase until we decide now it's time for downtime. And when we have downtime, we can do the final incremental backup and restore that, of course. Then we transport, which is the full transportable part. And at the end, we clean up. So let's look how we do that. First of all, phase 1, database creation. Database or pluggable database needs to be created with the same compatible or a higher compatible value, identical database character set, national character set, time zone version, and also database time zone setting. Once this is done, we need the Perl scripts. And the Perl scripts can be downloaded via this My Oracle support node. They're called V4 for version 4, because these Perl scripts have seen some incarnations. And when you unzip the zip file, the 2 important files are marked in red here, the XTD properties, which is a text file, and the driver PL, which is the Perl driving script, which allows us to back up and restore and convert and merge and everything. And there are 2 techniques available. First of all, on the left side, RMAN backup and convert. This is the standard, and you would use XTD driver PL -- backup and -- restore. You can see in the picture that RMAN technique has one disadvantage. You need staging space. And as we create an image file copy backup of our database, and if our database is now 180 terabytes in size, we need 180 terabytes staging space. But then with the restore option of the Perl driver, we can restore, and if a conversion is needed, that will implicitly do the conversion as well. On the right side, you see I would say the more easier method with DBMS file transfer. DB's file transfer has the big advantage that you don't need staging space because it can take the file and convert and restore it to the destination in one pass, while Armin can only take a backup and then read that backup and convert and restore it in the second phase. This is why Armin needs the staging space. The convert happens implicitly with the file transfer method, but the version 4 Perl scripts don't support this method anymore. Still, if you want to use it, you can use it, it still works. Second thing is, in phase 1, we need that XTD properties file. We get it with the download, but we need to modify it. And don't be puzzled by all this text. A lot of this text is just meant for explanation. Basically, when you look at the table spaces on the left side, this is the most important part. You have to define which table spaces you'd like to transport. You define the source platform ID, and the destination platform ID automatically will be detected. And then you specify all these locations where your files are, where the incremental backup level 0 should go to, the level 1s should go to, and where you finally want to restore. So first step here with the Armin method is we take a level 0 backup. And as I explained, if my database is 180 terabytes, I need staging space. So minus backup starts taking an incremental level 0 backup, which is no incremental in this case. It's an image file copy backup, stores it in the staging location, and in addition creates this res.txt, which I need to SCP over to my target platform. Now with that file being on the target side received, I can there start the XTD driver PL -- restore. And if a conversion is needed, it will detect it automatically and implicitly will do the conversion for you. So no extra work needs to be done. Then I can go to phase 3, and phase 3 are now the incremental level 1 backups, the difference between my end of level 0 and now. So again, XTD driver PL -- backup, and again, copy the res.txt file over to the other side. And once it's received in a staging location, I can restore it. Now, the cool thing is, convert happens implicitly, and it will be merged into the existing one. And we can repeat that. So typically, we repeat this a few times, and we increase the frequency. So the more often we do this now, the smaller our backup pieces get. So the idea is increase the frequency, make it run faster. And for the final step, because then we have downtime, we need to set now our source database read-only. This is downtime. And then this final incremental backup should be very small. This is the last step. Just take the final incremental backup and then restore and merge it into my target. Now the files are in shape, they are there. And at this point, I call now full transportable export import. In my example, I do it on a database link here, because then I avoid even writing a dump file down here. So I run impdp on my destination side with full yes and transportable always. And you see here the command. If you talk to an 11 database, you need to take version 12, which is here in brackets. If your source is already a 12 or newer database, you don't have to use the version parameter anymore. It detects that automatically. And that's it. It will rebuild now the dictionary. It will create my users. It will import the file information, because my files are there, but they are not known to the database yet. So it will import all that and then rebuild my entire logic, all the meta objects in my database. And once I'm done with that, I clean up. So ideally, I verify with an Armin validation that my table spaces are all good, everything is fine, and then I remove the XTD properties and whatever are the leftovers, clean out the staging location, and so on. And that's it. Now let's bring this a step further and push the limits a bit with 1,500 databases and an ExaCC migration using a zero data loss recovery appliance. So we do cross-platform, big endian AIX to little endian Linux, but we have also some Linux databases, some Windows databases in that case here. The options we have is data pump, which we know now, maybe like work with all the databases, but not the fastest solution. And we have some very big databases here as well. So it may not be working with the downtime restrictions we have. Transportable table spaces, that would be a good idea, maybe with ARM and incremental backups. But still, we know that we have to program a little bit around it, or full transportable export import, which in this case generated with the versions we had some unforeseeable log errors. The goal was we find an all-purpose migration path which applies to all databases. So not 3 or 5 different solutions, just a single solution which works with everything. And a decision was taken at some point that we customize a transportable tablespace solution, and we utilize the Zero Data Loss Recovery appliance as our migration vehicle for the cross-platform incremental backup restore. So this is the strategic overview. We have the AI access, mostly, then incremental backups written to the recovery appliance, and there they get converted, restored, recovered to the ExaCC on the right side. Then we do the transport steps, which means we plug in the files, and at the end, we rebuild all the meta information. And for that, we create scripts. Of course, in order to repeat the incremental steps, we start with a level 0 backup, then incremental level 1s, another incremental level 1, maybe another one and another one. And then we do the TTS steps, plug in the table spaces, and then the meta operations, rebuilding the users, the quotas, the privileges, all that stuff. And we split this now in 2 parts. First part is the recovery appliance. Second part will be the transportable table space part. And for the recovery appliance, we offer special customized Perl scripts. So DB, database, MIG, migration, use, recovery appliance. DB, MIG, use, RA, PL, Perl scripts, and we will use them. Because these Perl scripts allow us to automate and use the recovery appliance as our perfect migration vehicle. In order to do so, we need a most recent lib RA, lib recovery appliance SO on all these machines, because this is like our tape library, and this allows us to trigger all the things we want to do and use the recovery appliance. And you see it's available for all these platforms. Then we need a package with the scripts, so DB MIG use RA Perl, including also a special XTD properties. So this is founded on the basis of the V4 Perl scripts we have talked about before, but it's customized especially for the recovery appliance. And this is that XTD properties here. So the most important thing is the second line here, SBT lib parms, because this points to the lib recovery appliance. When you look to the very, very right of the slide, lib RASO. Then parallel 16, the table spaces. So we know already that for each database, we need to configure or build that file fitting for each database, because the table spaces have different names there. Then storage on disk. This is the ASM disk group where or directory where the files will be restored to, and some basic parameters. Very simple. Now let's start with the level 0, the image file copy backup. So if I have a 180 terabyte database, I need 180 terabyte on the recovery appliance, of course, and then I restore it, and this will also do the conversion. Once I have that, I can now start doing my incremental level 1s. So the difference between end of my level 0 and now, minus minus recover. And I repeat that step as often as I want. So typically we do this 2 times. The idea is get the final incremental backup for the cutover really as small as possible. And then let's focus on the second part, the transportable table space part. And here, may I introduce you to Sona Toraman. So he was the guy at the customer at Metronome. This is the IT of Metro, 4th largest retailer of the world. And he directed all that from his position. So what we do is here now, with the help of Oracle ACS support, we create customized transportable table space scripts, and we use them. So at first, we build up a check script, simple SQL script, which does things like special checks on our database. We had packages in the system table space, which had to be moved out, or objects anyways. taking note of the size of the database, the table spaces. Very important, I can tell you, the object count for meta objects, because if you have your entire database migrated over, it's to run a check script comparing if everything is really there, doing an AW extract, doing plant captures and such. Then preparation work on the ExaCC. In this case, everything is in pluggable databases, so we need to create the pluggable databases correctly. We were lucky and in a very generous position. All the source databases were already on Unicode, so we had not to create any special things for the CDBs. So we can just provision new PDBs. It was already in the right character set. We just had to make sure that it's also the identical time zone version. Then every PDB at this stage got a users table space, which we renamed right away to users drop me later. And I come to this idea why we want to drop it, but our source databases had user table spaces already. So this was just meant to avoid any conflicts. And when we were running tests, we set a GRP to avoid that we have to rebuild the PDBs all over again. Then on the source side, we had to do some prep works, like moving out objects from the system table space. As you know, you can't transport a system or sysargs table spaces because you can't set them read-only, so everything needs to be moved out. And now we generate a lot of scripts. We generate scripts to set our table spaces read-only and read-write. We set our scripts to, or we create scripts to create dummy table spaces. I'll explain in a minute why dummy table spaces, and also reverse that, creating the temporary table spaces, the user, the profiles, grants, roles, directories, grants to materialized use, DB links, also for create functions. You need to create a function first before you can import the table using a function in a column, or same for index. Don't forget us the global temporary tables. We forgot them once. And of course, for the XTD properties file, the table space list needs to be created as well. Then we do the level 0 backup, the level 1 backups, and repeat that. No downtime involved here. And on the ExaCC, before we can go forward now, we create profiles and we create dummy table spaces. Why do we create dummy table spaces? The reason for that is when you do transportable table spaces, normally you need the user first, but you can't alter the user correctly because you can't tell Scott, hey, Scott, your default table space is users, because this is the table space you transport afterwards. So normally you end up in a situation where you create like a basic user, then you transport a table space, and then you alter the user. So here we had this idea saying, let's create the table spaces we need upfront because we have the table space list already, but just with 100 megabyte each. Then create a temporary table spaces and then create the users correctly right away. Because at this stage, I can create Scott and tell Scott, hey, Scott, your default table space is users. You have a quota of 10 megabytes on this table space. I drop this dummy table space afterwards, but the user stays exactly as it was before. And so when the real table space is coming in later on, the real data table space with 18 terabytes, the user is set up correctly right away, and I don't have to alter the users anymore afterwards. I create grants, roles, and so on, and then a special file, which is part of this XTD move here to generate the transport data file strings. Then, now, stop sign. Application goes read-only. Table spaces go read-only. Final level 1 backup. Restore, convert, recover, or otherwise convert, restore, and merge. And once we are done with that, now we can start with our transportable table space part. So it has two pieces. First of all, we do a final metadata export. We can do this just now because we can't ensure that there's a freeze before on the application, so it needs downtime. But it's not a super long action. Maybe it takes 15 to 30 minutes to generate this one here, which has the final functions, packages, procedures, database links. It's more or less going into the dictionary. And then the TTS export part. So this is what is our table space and what is inside that table space. Tables, indexes, types. It was very beneficial to generate fresh statistics beforehand in the dictionary by gathering schema stats on sys and system. Then, once this is done, we can go over now to our PDB. We do the TTS import, which means now we plug in the table spaces to our pluggable databases. Table spaces are now attached, automatically go into read-write mode. And then we rebuild with the metadata import what has been left at the beginning. So we rebuild the normal functions, not those which are used in tables and columns, packages, procedures, database links. You can't rebuild password-protected database links with a script because it doesn't give you the password. Only way to rebuild them is via data pump. Sequences, very important, views, synonyms, in that order. And finally, we cleaned up, dropped the guaranteed restore point. We did some other treatments. We ran the check script to compare before, after. And finally, if everything was there, we triggered the online encryption on ExaCC, which is a feature available since 12.201. And that's it.
So thanks to all those detailed explanations and step-by-step approaches, I think you've probably figured out that transportable table spaces is a very powerful technique for migrating large databases cross-platform, cross-endian, even cross-database architecture. But even with all of that, with incremental backups involved, I would never promise that you could get down below, say, tens of minutes of downtime for a really major migration of many terabytes of data. If you want to get the least downtime possible, and really who doesn't, what you want to look at now is GoldenGate. So let's talk about what GoldenGate is, what it isn't, and what it does and doesn't do. And we'll start at the high level, explaining the concepts of GoldenGate and maybe some misconceptions about it. And the first misconception that I want to get into is the idea that GoldenGate is performing a migration. GoldenGate is not there to perform the migration. It's there to eliminate the downtime of migrations. It has a lot of other uses too, by the way, for things like asynchronous replication across different architectures, different data models, different databases, and so on. But in a migration use case, it's there to cover over the downtime. So you'll always start with an initial copy of that database, whether you're using data pump, transportable table spaces, even an RMAN backup and restore could be that initial copy. What GoldenGate's going to do is while that copy and instantiation is taking place, GoldenGate captures statements on your source database, which is still in use by your users. And then later on, it can then replay those statements. So kind of a logical replication into that target database, which could be on a different platform, different version, have a different topology inside it, even a different database architecture. So as we replay those statements, we will catch up. And once we catch up, you can make that switch over with minimal or even, in some cases, zero downtime. So the advantages of GoldenGate, maybe even true zero downtime. And I don't use the word zero lightly. You'll often see people talk about zero downtime when they mean near zero downtime. But with GoldenGate, there are plenty of cases where you can use it to get true zero application downtime. It's very flexible. It goes cross-platform, cross-version, cross-endian, even from non-Oracle databases into Oracle. It can handle basically any migration that you've got, including upgrades from old versions. Like let's say you have a 9i database where you're going to have to use original export-import to move it into Oracle Cloud. Well, GoldenGate can cover over the downtime, which with original export-import could be significant. And GoldenGate can bring that downtime down to almost nothing. It has good fallback capabilities, which we'll talk about. And if you have the GoldenGate license, and remember, under considerations, it is an additional licensed option, but with the GoldenGate license comes Active Data Guard. So now let's go back and look at how we would use this to do a migration and perhaps an upgrade. You've got users active on your production database that you're going to be migrating. They're performing their normal operations, your normal transactions. You create your initial copy of that database. Maybe this is a data pump export and import, and it's a 15 terabyte database. So it takes you the better part of a day to do the export. copy it over to the new platform, do the import. All the while that that's happening, we're capturing statements with GoldenGate on the source database. So we're building up these trail files on the server, and then we copy them over to the target. Now, we don't apply those yet because we also want to upgrade our target database. So not only are we copying the database over, but maybe we're doing some sort of upgrade. It could be that data pump import. It could be a backup, restore, and upgrade. Once that is done, then we replay the statements into the target. And once we've caught up, then we switch the users over to the new database. So in this basic GoldenGate involved migration, the downtime is however long it takes to switch your users from the source database to now connect instead to the target. But there's more. You can have reverse replication. After you've migrated to the new environment, you can have a nice fallback possibility by having reverse replication from, say, 19C back to 11204. And then if for some reason you decided that 19C wasn't cutting it for you, you could switch the users back to 11204 without having lost any data. And in fact, you can even use GoldenGate in a bidirectional replication, where you can have some of the users migrated and testing out performance, others are still on the old system. GoldenGate has conflict detection and resolution so that you don't have people updating the same rows and stomping all over each other's updates. So it's a very versatile, very powerful tool for any kind of migration. I mentioned way back when we talked about Data Pump that it used to be with Data Pump, when you're migrating, you had to have a consistent export. Well, with GoldenGate, you don't have to have that consistent export and build up all of the undo and accumulate undo for the length of your Data Pump export, because starting in 12.2, GoldenGate has what it calls instantiation filtering tied into Data Pump. In other words, what it does is it keeps track of the SCN at which Data Pump exported a table. And then it plays back operations on that table only starting at that SCN. So while you might start capturing very early on at the beginning of your Data Pump export, your last table might not have been exported for hours later. GoldenGate has captured all of that information, all of the changes on the table, but it's smart enough to know that after the import, it only has to replay a subset of those changes, the ones that took place after that individual table was exported. So this is a replicat parameter. You can see the Moss note there that's referenced about how to use it. There are technical briefs about using GoldenGate for migration, one with the GoldenGate hub configuration, another about using zero downtime database upgrade. That's a facility that uses GoldenGate and some pretty smart cloning to do a zero downtime upgrade in a rack environment. Kind of cool. So you might want to pick up those technical briefs. Now, another thing about GoldenGate is that it does have a lot of similarities to the old Oracle Streams feature that has been desupported in 19C. Now, Oracle Streams was deprecated back in 12.1. And remember last webinar when we talked about multi-tenant, I explained the difference between deprecation and desupport. It was deprecated in 12.1. Streams is desupported in 19C. It's not available. The APIs have been removed. And Oracle Streams has never worked with multi-tenant container databases anyway. So with Streams being desupported, you would want to migrate to a different replication technique if you have been using Oracle Streams up to this point. Our recommendation would be GoldenGate. And we do realize that that is an extra cost license, but that is our recommendation. Now, Streams is related to the AQ feature, advanced queuing for communication between different entities in the database. Advanced queuing is not deprecated. It is still fully there in 19C. If you want to migrate from Streams to using GoldenGate, because GoldenGate is, after all, more powerful, it has fewer restrictions, it's easier to manage, it's faster than Streams, so it has a lot of advantages. Anyway, there is a utility about migrating from Streams to GoldenGate, and it is, again, referenced in a support note. So that's the kind of basic overview of how to use GoldenGate and get the minimal downtime of a migration. I think that's our last of our migration topics. So now let's talk about after the migration and how are you going to make sure that your migration, your migrated database is successful in terms of performance. Daniel, can you take over here?
Okay. Now let's briefly touch upon performance after migration. Previously, we have already covered this in a full 2-hour webinar where we talked about all the tips and tricks that you can use to ensure good performance even after migration. If you haven't seen it already, I would strongly recommend that you watch the recording and flip through the slides to get the latest and greatest information on how to ensure a smooth operating database even after the migration. Now, the following that I would like to talk about applies only to logical migrations. So these are the situations where you use either data pump or transportable tablespaces. First, I would like to cover transporting statistics, because by using the DBMS stats package, it's possible to take optimizer statistics from one database and put them into another database. And typically you do it either on schema level or on table level. When we talk about migrations and transporting statistics, we often see it useful when you transport your data from a very old version of Oracle into, for instance, 19c. In 19c, the optimizer has access to new and improved histogram types, for instance. But in order to use that, you have to regather statistics on your data. If you don't have time to do that within your downtime window, but you would still like to get access to those new optimizer features, you can transport statistics from a comparable test system, it has to be comparable, into your production database, thus getting access to new optimizer statistics, but without having to regather them. And also, when you use data pump, it is much faster to transfer your statistics using DBMS stats than data pump. So how does it work? Well, in your source database, you have your user data. In this example, we call it sales app, and you have the data dictionary. And it's in the data dictionary that the optimizer statistics are stored in some very cryptic format. So in order to transport that, we first have to create a staging table, which can hold a transportable format of the statistics. We can then unload the optimizer statistics from the data dictionary and into the staging table. And since the staging table is just a regular heap table, we can export it with data pump. Then on our target system, we start by transferring the dump file. Then we can import the staging table to our sales app schema, and then we can unpack from the staging table into the data dictionary, and now the optimizer can get access to those good statistics. I have prepared a little demo where we can see how you can do it. First, I'll create a schema and just add some sample data. I'm creating a user called sales app and I grant DBA, so don't do that at home. Now I create a regular table and populate it with some data. I then create an index. And now the next step is to gather and check our statistics. I gather stats on the table. And I can see now that my basic table statistics have been populated. Also, I have column level statistics, including histograms. And I even have index statistics. Now it's time to export the statistics. I first create a staging table, and then I export the table statistics from the data dictionary into the staging table. I create a directory that I can use with data pump. And now I simply start data pump and I export the staging table. Oops, there it is. Now, In my target system, I'm creating an empty schema, and then I gather stats. So I'm on the target here. I create the same schema. I create a table, but I use the predicate to just create an empty table. I create an index and gather stats. So let me check the statistics. Yes. Luckily, they tell me that I have an empty table, no data. The column statistics say the same. I don't have histograms. And luckily, index statistics reports 0 rows as well. So let's import the statistics. I first create a directory that I can use with DataPump. Then I simply start DataPump to import my staging table. And there it is. Now I import my table statistics. I take them from the staging table and put it into the data dictionary. The version of the staging table is from a previous version, so I have to upgrade the staging table before I can then do the import. So now let's have a look at the statistics. It's an empty table, but the basic table statistics report around 200,000 rows. I have column level statistics as well, including histograms. But in 19c, there are additional columns and they don't get populated. It still works. And my index statistics are good as well. So this is an easy way to take my statistics from the source system and get them into my target database. The optimizer only uses statistics that are stored in the data dictionary. So if you have statistics in your staging table, it's safe to keep them there. They won't be considered by the optimizer. When you import statistics, they are marked as current, which is the opposite of stale. That gives you the benefit that the automatic maintenance task won't regather statistics on your table after you have imported statistics. They are not considered stale. You can transfer statistics from a lower version to a higher version, but potentially you have to upgrade the staging table, the stats table, but that's a very trivial operation. And important, if you're using partitioning and you're using incremental statistics, you should be aware that by default, the synopsis information doesn't get exported together with the optimizer statistics. It is still possible, but you have to specify it yourself.
Now, finally, we would like to show you how you can transport SQL plan baselines and SQL profiles. During a normal database upgrade, they just stay in your database, so no extra action is needed. But for a migration, you must make sure that plan baselines and profiles get migrated as well, if you want that. Plan baselines are stored in data dictionary, and by default, you don't migrate your data dictionary. So you need to find a way to transport them. And this is very simple and straightforward. You need to create a staging table. So the DBMS SPM package has a create staging tab baseline procedure, and you define a table name and a table owner. Then, in this example, we select all fixed and accepted plans to be moved into that staging table. So we use, again, DBMS SPM pack staging table baseline, and we do this for enabled yes and fixed yes. Now our plan baselines are in the staging table. If you have created it in a user schema which you migrate, then you don't have to do this step. But in case you use the separate user like we do here, then the easiest way is you create a database link from target to source. And then on the target side, you run impdp over this database link, and you just move tables here, our staging table. Once the staging table is now received on the target database, you unpack the staging table baseline, and this will move the plan baselines into the dictionary of the target database. So it's not complicated. You just need to make sure, if you plan to move your plan baselines, to take this extra step, because by default, they are not migrated over. And the same applies to SQL profiles. So also for SQL profiles, we need a staging table, because also they are stored in the data dictionary. So again, here now from DBMS SQL tune package, create staging table SQL prof, needs a name and an owner. Then we select the profiles we want to transfer. And now the profiles are grouped into categories. And if you never dealt with categories, then you just use the default category, and profiles which exist in your database are visible in all sessions to the optimizer. And so you would use pack staging table SQL prof and don't specify any categories. If you have defined categories, you can add here specific categories to just put SQL profiles from a category into this staging table. Then you need to migrate the staging table over. Unless you created it in a user schema, you migrate anyway. And again here, create a database link and then imp dp on a database link for this table and move it to the target database. And once it's received there, you load the profiles from the staging table into the dictionary with DBMS SQL tune, unpack staging table SQL prof. And this with replace true. And this puts now all profiles from the staging table into your target database's dictionary. And they will be valid right away. So I think you just need to add this to your migration plan. And once this is in the migration plan, all is good and it doesn't get forgotten.
Well, that's certainly a lot to take in. And if you've made it this far, thanks for sticking with us. I'd like to give you just a few closing thoughts to maybe help boil down all the different things we've talked about and organize your thoughts. First is this table that we have showing the applicability of the different migration techniques to the various characteristics of a migration project. It could be the types of changes you want to make to the database, or the downtime involved, whether you're going cross-platform, cross-endian, whether you've got encryption. There are lots of things that you might have to think about. The last thought that I want to leave in your heads is that there is this tension between simplicity and downtime. We know that every one of our customers would love to have a migration strategy that is zero cost, zero effort, zero risk, and zero downtime. And unfortunately, that strategy doesn't really exist. You've seen that all of the tools are there to accomplish the migration that you need to accomplish, whether it is a minimal downtime cross-platform one where you're implementing TDE or something like that. But the more change you're implementing and the lower downtime, the more complicated it's going to be. It's simple as that. So if simplicity is your goal, then you need to accept downtime. If downtime reduction is your goal, then you need to accept a little bit of complexity. So with that, let's take you out to the end of the webinar. Well, that's the end of the 5th webinar in our series. Thank you for attending today. We hope you enjoy the session and that you've taken away some useful input for your next migration.
Next time, we will take it a step further and migrate your database up there to the cloud. And there you'll see that many of today's topics will be very useful again. So I really hope to see you next time for some more fun.
Yeah, and as usual, we will hang around for a little while in the chat to answer all the remaining questions. We hope you enjoyed the seminar with us. And of course, we hope to see you again the next time. Thanks. Until then, take care and happy migrations. Thank you. Bye.